We've just discussed capacitors in some depth in the last videos, and I don't intend to go into as much depth with inductors, because in many ways their electrical behavior is just the opposite of capacitors, and also there's plenty of videos on the internet which explains their in-depth operation if you're interested in this anyway. So let's have a look at their basic behavior. An inductor is just a coil of wire. Like a capacitor, it can store energy and it can release it. However, this time it stores it in a magnetic field around itself. In other words, it's an electromagnet. When the current through it is stopped, the magnetic field collapses, causing a voltage to appear in a reverse direction and a current to flow if it's connected to a circuit. This is called the back EMF. One difference between an inductor and a capacitor is that a charged capacitor will retain its charge when you remove it from a circuit. However, in an inductor, without a current to sustain the magnetic field, the energy just disappears. The amount of energy stored depends on the inductance. This is equivalent to capacitance in a capacitor and is measured in henries. Again, rather like a capacitor in farads, inductance is a rather large unit, and so you're more likely to see millihenries or nanohenries or microhenries. Like a capacitor, an inductor does not dissipate energy. When the flow reverses, the energy contained in the magnetic field returns back to the source. Also like a capacitor, and for again rather similar simple reasons, the voltage and current in an inductor are out of phase by 90 degrees. However, this time the voltage leads the current, the opposite way round to a capacitor. Also again, the opposition to current flow depends on frequency. However, this time it's the opposite to a capacitor. An inductor opposes flow more and more with rising frequency. You can see from common sense that a DC, an inductor being a coil of wire, will just be a short circuit. So like a capacitor, an inductor has reactance. X equals V over I. The reactance though is different to capacitors because the current and voltage have the opposite phases. The graphs on the screen show how the reactance of the inductor varies with frequency and show the other formulae and the phasor diagram which we covered with the capacitor as well.